This is a very easy slide to understand and to interpret. This is a slide of ground bone. Ground bone is not prepared in the traditional way of sectioning the tissue, but because it's so calcified, this is actually a sliver of bone which has been ground on a grinding wheel until it's thin enough to be transparent. And so this section has no stain on it. And the contrast which you see is just based on the thickness and constituents of the bony material itself. If we move up a little bit in magnification, osteons cut in cross-section and so presenting a circular appearance are immediately apparent. And you can see that the osteons aren't perfectly regular in shape, but rather that they tend to be a bit variable. And you can also see regions, say for example here, where there may have been an osteon in the past and perhaps there's a little bit of remodeling that's either going on just now or has gone on. If we increase in magnification again, and if we concentrate really on just looking at here is one osteon here, here's another osteon here. The center part of the osteon is the Haversian canal, and the fact you can see some dark material in it is indicative of where the blood vessels and nerves and so on, and the endosteum that would have lined that canal, Haversian canal, would be found. And finally, if we move up into the highest end of magnification, so here, and if we pick just one osteon, let's take this small one in the center here. So here's the osteon itself, here's the Haversian canal, and surrounding Haversian canal in concentric layers are the osteocytes, the bone cells which have been trapped in their bony matrix. And you'll know from the lecture notes that one of the key features of osteocytes is that although they're trapped inside a bony matrix, they're not isolated, but in fact remain in communication with one another. And as we move to the maximum magnification, we'll see the structures which enable these guys to communicate. Each of these osteocytes trapped in its lacuna extends thin tendril-like processes out through the bony matrix in small canals called canaliculi. And these processes make contact with, and if you like, speak to the surrounding osteocytes. So here's an osteocyte. Here are the processes extending out in the canaliculi. These canaliculi extend all the way into the Haversian canal, where there will be communication between this osteocyte and some bone-lining cells. And if we were to look over here, we can see that there are connections between these canaliculi this would be from another osteocyte, maybe out here somewhere, and these connections enable the osteocytes to function together as a single unit.